Okay, in this class I want to look at developing formulas for trapezoids, specifically the area of a trapezoid formula. So a trapezoid is just a quadrilateral, meaning it has four sides, with exactly one pair of parallel sides. So these two sides would be parallel sides, and those two sides, parallel sides, are called the bases of the quadrilateral. And we have a big base 10 and a little base 6. This blue shape is the quadrilateral. This thing here is just telling me about its height. Actually, it's a little bit in the way. Let me just move it out here. This is just telling me how tall the quadrilateral is. So the quadrilateral is 8 units tall. So that's what we're talking about. And before I talk about developing the formulas for the areas of a trapezoid, I want to just remind you how we found the area of a triangle. And we did a series of things actually. We defined what a unit square was a definition, and from that we were able to come up with the area of a rectangle. The area of a rectangle was base times height, and from that we were able to derive the formula for the area of a parallelogram, which was also base times height. And then from that we were able to establish the area of a triangle, because a triangle is a half of a parallelogram, and the area of every triangle can be written as a half times its base times its height. That's how we find the area of a triangle. When it comes to trapezoids, where we have exactly one pair of parallel sides, every trapezoid can be split up in this way. If we draw a diagonal from one corner straight up to another corner, we have split our trapezoid into two non-congruent triangles. Those triangles will not be congruent. So I've drawn in a diagonal there, but you can see, hopefully you can see, that we have a triangle there and we have a triangle there. And we can find the area of each of those triangles. Why? Well, because we know their base and we know their perpendicular height, and we know the area of a triangle. The area of every triangle can be expressed as half of its base times its height. So if I look at this triangle over here, let's call these triangles, are these areas A1 and A2. So I want to find the area, say, well, let's look at A1, this one up here first. It's going to be half by the base times the height. So what's the base of this triangle? Well, this has the little base from the trapezoid of 6. So the base here is 6. And the perpendicular height from that base, and just rewrite that, that doesn't look like a 6. The perpendicular height from that base of 6, well, you know, to this point here is 8. We're talking about that height there. We know that height to that side is 8 units. So it's a half times 6 times 8, which is 3/8, which is 24. So this area is 24 units squared. The second area, again, it's the area of a triangle, which is always a half times its base by its height. But this has the big base here as its base. This is the big base here of 10. Its perpendicular height is exactly the same. It's exactly the same height as the other triangle, which is 8. So what we get is 5/8, which is 40. So the second area is 40. So from that we can establish that the area of the trapezoid is equal to 24 plus 40, which is 64 units squared. So we can find the area of a trapezoid pretty easily. Okay? And what I want to do is I want to take that process and break it down and derive a formula for the area of a trapezoid. The other name for a trapezoid is a trapezium. Trapezoid or trapezium, both are fine. So what do? We have a trapezium. That side has to be parallel to that side. Okay, if we have one pair of parallel sides, then we have a trapezium. We have a perpendicular height. Every trapezium has a height. And the perpendicular height of the trapezium, it's that length there. And every trapezium has two diagonals. If I draw in one of those diagonals, from this corner to that corner, So every trapezium has two diagonals. I'm just drawing in one of those diagonals. And that diagonal will break the trapezium up into two triangles. They will not be congruent, though. We're not talking about congruent triangles. We're talking about two non-congruent triangles, in fact, because they have different bases. So they will not be identical. Again, the trapezium is made up of the area of this triangle and the area of this triangle. A1, remember we said the area of any triangle is half the base by the height. So A1, that first area, is going to be half of this base, the little base, multiplied by this height. And A2 is going to be half times the big base here, A, times the perpendicular height, which is H. So the area of the trapezium is going to be 1/2 of AH plus 1/2 of BH, where A and B are the big and little bases respectively. And I can actually do a bit of, algebra here. I'm going to factor out the H. I can write that as H times. And half of A is just A over 2, so I might write H times A over 2 plus, factoring a H out of the second term, half of B is just B over 2. Combining these two terms into a single fraction, we're going to get that the area of the trapezium is equal to, well, common denominator there is 2, and that's A plus B on the top, and they're being multiplied by H. H times A plus B over 2. And this formula is in your formula and tables booklets on page 8. You need to be able to find it and use it. Thing to note here is that's the perpendicular height, not the slant height. It's not the length of one of these sides, it's the perpendicular height. And this A plus B over 2, that's just the average base length. Two bases are A and B. Remember, the bases are the parallel sides, not the other sides. So here A and B are the bases. This is not considered a base, neither is that. The average base length, add the two bases together, divide by 2. Okay? So there's my formula for find the area of a trapezium. Let me look at one more example there. So that's just deriving the formula. You got to know that. You've got to be able to put it into use. So let me look at one more example here. In this case, we're given the area of 252. I'm given the little base is 16. I'm given the perpendicular height is 14. I'm given the big base is A. We know the area of the trapezium is always going to be the height, perpendicular height, times the average of the big and little bases. So just substituting into my formula, the area is given here, that's 252, and that's equal to the perpendicular height, which you can see here is 14, times the average base length, well, that's A plus 16 over 2. Add the bases together, divide by 2. And now it's just solving a linear equation here, so I've got 252 is equal to, I'm going to factor out this division by 2 into this term here, so 14 over 2 will be 7, so I'm going to get 7 times A plus 16. I'm going to distribute on the right hand side. On the left I still have 252. 7 times A, 7A. 7 times 16, 7 times 70, 7 6 is 42. Combined gives me 112. To solve this equation, I'm going to use the subtraction property of equations, which says if equal quantities, in this case 112, are subtracted from both sides of an equation, then the two sides will remain equal. So I'm going to get 140 is going to equal to 7 times A. Okay, 7A equals 140. And I'm going to just solve that equation. Let me move that over there out of the way, using the division property of equations, which says if both sides of an equation are divided by equal quantities, in this case 7, why 7? Because that'll cancel that 7 out. If both sides of an equation are divided by equal quantities, then the two sides will remain equal. So on the left we'll have 20, and the right we'll have A. A is going to equal to 20 units. Okay, so actually I didn't need to find the area. I was given the area here. I wanted to find A. Okay, so that's trapeziums, trapezia, or trapezoids. Okay, questions at this stage? All this work is from section 9.1 in your textbook. You should be getting through that. We'll be moving on to section 9.2 in the next class.